Hello students, till now we have seen the extension of the Rankines theory to surcharged backfill, submerged backfill and inclined back of the wall. So in this video we are going to discuss the extension of the Rankines theory to the inclined backfill. Case 5. Backfill with inclined surface or sloping surface. Then the retaining wall, say vertical back of the wall, but inclined backfill. Now considering an element of soil at a depth of Z, an element of soil at a depth of Z from behind the wall, it is seen that the element will be subjected to a vertical stress of sigma Z, which is the weight of the soil column above the element, and the lateral stress is sigma X, which is inclined as beta from the horizontal. That the inclination of the back of the backfill is beta. Now the element is seen to have inclined top and bottom surfaces, but vertical side surfaces, carrying lateral pressure as sigma X and vertical pressure as sigma Z. Since sigma Z is the vertical pressure coming from the weight of the soil column above the element, it is unit weight of the soil into area of the plane area of the column with depth as unit, because B is the width of the column, small b, inclined width. So it has to be cos beta. This is the force or weight by the area of the surface of the element, top surface of the element is B into 1 unit, that is B into 1 or B. It gives you B cancels, only gamma Z cos beta is the vertical stress. Sigma X, which is our requirement, that is lateral pressure, has to be determined. Now because sigma X and sigma Z are conjugate pressures means conjugate forces. Conjugate forces means the forces are such that the plane of inclination of one force is parallel to the direction of the other force. Therefore they are conjugate and they are having equal obliquity of beta. With these conjugate stresses sigma Z, sigma X with equal obliquity beta, we can draw the Morse stress diagram for the element under stresses at sigma Z and sigma X. So the Morse diagram will be, let us see the Morse diagram. If this is the Morse diagram, now with sigma Z and sigma X with equal obliquity beta, we can draw, they are none of them are principal stresses, they are oblique stresses. So sigma at beta, we can mark OP and OQ as sigma z, OP as, if it is O, OP and OQ, OP is sigma x, OQ is sigma z. Both are with equal obliquity beta. This is P, this is Q. OQ is equal to sigma z and OP is equal to sigma x, and both are inclined at beta. So from PQ, if we erect a perpendicular bisector of PQ, it will be from here, it will cut the x-axis at a point, let us call it F. F. Now with F as the center of the Mohr circle and FP or FQ as the radius, we can construct the circle or semicircle, which is the Mohr circle of stress. And the Mohr circus is ready. Mohr circle is ready. Now, the strength envelope of the type or with the property of the soil, because it is from the beginning it is dry and cohesionless, so the strength envelope will be at 5 degrees and it will be tangential to the circle because the element is at the failure stage, plastic stage. So it will be tangential to the strength envelope. And the point of tangency, say it is A. Let O, where the circle cuts the axis, it is E. And this point where it cuts the major principal stress, this will be D. OD will be major principal stress, OE will be minor principal stress. Now, PF is the radius, the perpendicular point at which between PQ is, let it is called B. Now, we have OP is equal to sigma s and OQ is equal to sigma z. So we can write sigma x by sigma z. The ratio between the two stresses, sigma x and sigma z, is OP by OQ. If we see geometrically, OP is simply OB minus PB. Can write as OB minus PB. Similarly, OQ written as OB plus BQ. But because PB and BQ are equal, we can have OB minus PB and OB plus PB. In place of BQ, you can write PB. Now, we'll see what is OB and what is PB. These two things have to be searched. So we can see OB is cos beta of OF. So OF cos beta, but OF is mean of, say this is D means major principal stress, we call it sigma 1. Minor principal OE will be called sigma 3. So OF is the mean of sigma 1, sigma 3. So sigma 1 plus sigma 3 by 2 cos beta. Now what I want to say is that the ratio of the stresses will be in terms of this length of the lines. Now again the length of the line will be expressed in terms of some stresses. So now again we have given these things as sigma 1 by sigma 3 by 2 cos beta. Now OB has been expressed as the ratio of sigma 1 sigma 3. Similarly, we'll try to express PB as the ratio of some ratio of sigma 1 sigma 3 in terms of sigma 1 and sigma 3. So PB is equal to cos of some angle. Suppose this angle is, let this angle is something, say omega. So we can write PB will be PF PF cos omega. Now the problem is we have to write in terms the PF and cos omega. Omega has to be written in terms of the known angles like beta, phi or theta, beta or phi, or PF will be in terms of some stresses like sigma 1 and sigma 3. To find the value of omega, we'll see PF sin phi will be equal to BF, and also OF sin beta is also equal to BF. So PF sin omega, the omega angle is such that PF sin omega is equal to OF sin beta. So sin omega is equal to OF by PF sin beta. Now we are trying to find the values of omega in terms of sin omega and cos omega. OF, PF. Okay, we'll see in the next page. Say sin omega is OF PF sin beta. OF is not a problem, but PF is a radius, PF is a radius, and FA is also a radius. So we can write OF by, in place of PF, we can write AF also because both are radius, sin beta. Now for OF, AF, OF is equal to mean of sigma 1 plus sigma 3 by 2, and AF, because it is radius, it is sigma 1 minus sigma 3 by 2. So OF by AF will be OF by AF, it will be simply sigma 1 plus sigma 3 by 2 by sigma 1 minus sigma 3 by 2 becomes sigma 1 plus sigma 3 by sigma 1 minus sigma 3. Of now sin omega, we need actually cos omega. Cos omega is equal to root over of 1 minus sin square omega. Sin omega is found out to be OF by sin beta. Sin omega since sin omega is OF by AF sin beta, this OF by AF in this figure, OF by AF H by P in this triangle OAF, this is 1 by sin phi, so it is sin beta by sin phi. So cos omega is equal to root over of 1 minus sin square beta by sin square phi, cos plus minus. Now PB is completed. PB is now PF cos omega. What is PF? PF is sigma 1 PF is the radius. So PF is equal to sigma 1 minus sigma 3 by 2, and cos omega is this one, 1 minus sin square beta by sin square phi. So finally our ratio sigma x by sigma z, which was OB minus PB by OB plus PB, can be rewritten as OB. In place of OB we can write half of plus 1 by 2 sigma 1 plus sigma 3 cos beta minus, for PB we can write half of sigma 1 minus sigma 3 root over of 1 minus sin square beta by sin square phi by, again OB, half sigma 1 plus sigma 3 cos beta plus, for PB again same, half sigma 1 minus sigma 3 with the root over of 1 minus sin square beta by sin square phi. This, after some resolution, some steps, comes out to be and deducting sigma 1, sigma 3, everything will be deducted. Finally it will be sigma x by sigma z. It is going to be cos beta minus plus root over of sin square phi minus sin square beta by cos beta plus minus root over of sin square phi minus sin square beta. Because our search is sigma x, which is going to be known as lateral earth pressure, and because it is active earth pressure, we can write this sigma z into cos beta minus root over sin square phi minus sin square beta by cos beta plus root over of sin square phi minus sin square beta. Here the point to be noted is that in place of minus plus and plus minus, there will be two values of this one, the ratio sigma x and sigma z. I have taken minus first because of the active pressure, because it is going to be the minimum. That is why I have taken the negative one only. We have overlooked the positive values. So accepting minus and the numerator is negative, denominator positive, so that will give a minimum value. And we'll write sigma x as PA, active earth pressure. It becomes sigma z, and because sigma z has already been determined as gamma z cos beta, so now active earth pressure is gamma z cos beta into cos beta minus root over of sin square phi minus sin square beta by, again, cos beta plus the same sin square phi minus sin square beta. But for simple look, for easy to remember, the formula is converted to only cos form. So active earth pressure, again written as gamma z cos beta into cos beta minus, if we change sin square as 1 minus cos square and sin square beta as 1 minus cos square beta, it will be root over of cos square beta minus cos square phi by cos beta plus root over of cos square beta minus cos square phi. This is active earth pressure expression. In this expression, leaving gamma z aside, the remaining part is given a name which is coefficient of active earth pressure, Ka. So Ka, coefficient of active earth pressure, is cos beta minus root over of cos square beta minus cos square phi whole by cos beta plus root over of cos square beta minus cos square phi. This is the equation or expression for coefficient of active earth pressure with inclined backfill. And active earth pressure is finally Pa, Ka as usual, Rankine's theory, Ka gamma z, in which Ka will be this one. So the point to be noted is that if the backfill is not inclined, if it is horizontal, that means beta is 0. So putting beta in this equation, putting beta is equal to 0 in the same equation will be, it is interesting to note that the same expression with beta 0 will give you 1 minus sin phi by 1 plus sin phi, which is the same as the Rankine's active earth pressure theory's coefficient of earth pressure. Okay, that's all. Now with this is intensity of earth pressure. Now again P, total horizontal thrust, Pa will be as usual, it will be half K gamma h square, and the thrust will be inclined at beta. The inclination of the horizontal thrust, it will not be horizontal, it will be parallel to the surface of the backfill. That is, inclination of the Pa will be the earth pressure intensity will be parallel to the surface, backfill surface. So it will be like this. It will be again a triangular diagram, but inclined stress distribution diagram, and the final thrust, which is equal to Pa gamma, this one, it will be also will be equal to this one P, but it will be also inclined. The inclination of the final thrust from horizontal will be equal to beta as the surface of the surcharge beta. That's all. Okay students, so our next video is going to bring you the extension of Rankine's theory to cover the cohesive backfill. So see you in the next video. Thank you.